Hello everybody and welcome back to another visual pattern challenge. We've got a strange looking one today. Here's step 1 of our pattern, here's step 2, and here's step 3. And your challenge is to determine the number of watermelons in step 4. If you can do that, can you tell how many in step 43? And can you write an equation that could predict the number of watermelons in any step at all? So that's the challenge. If you'd like to accept it, pause the video and see what you can do. So this one is a little strange because the watermelons are cut into fractions. So we've got half watermelons, and then these ones on the corners are 3/4 of a watermelon. So we're going to have to do a little bit of fraction addition to try to get the number of whole watermelons in each step. I don't know if the answers will come out as whole numbers or fractions. So that's a slightly new challenge. But otherwise, I think this is a pretty normal looking pattern. It doesn't seem to be growing too fast. My first glance looking at this is that it's going to be linear. We've got this sort of frame of watermelons. It's getting slowly bigger. So let's see if we can think about how big the last or the next frames in step 4 is going to be. We've got the 4 corners that are 3/4 of a watermelon each. And then what's in between them? Well, first we have 1/2 of watermelon, and then 2 halves, and then 3 halves. So I would think, well, we'd have our corners, right? So there's our corners. And then we'd have 4 halves on each side. So 4 halves here, and 4 halves here, and 4 halves here, and 4 halves here. And 4 halves, well, 4 divided by 2 is just 2. So that's 2, 4, 6, 8. So 8 from the sides. And then how about this 4 3/4 watermelons? What is that? Well, one way to think about it, you could start splitting these up. If I took a quarter off of this one and put it into this one, that'd be whole. And then if I took a quarter off of this one and put it into this one, that'd be whole. And then I'd have those 2 halves left. So 2 wholes and then 2 halves. So there'd be 3 wholes. So that should be 3 for the corners. And another way to think of that is you have 4 times 3/4, because each melon is 3/4 of a melon, and 4 times 3/4, well, that would just cancel like that and give you 3. So either way, it comes out as 3 melons. So it looks like in step 4, I'm going to have 8 plus 3 melons, or 11. All right, let's see if we can actually calculate this now for all of the steps so we can analyze the numbers. We'll make a chart here with the step number and the number of melons. So in step 1, now the corners are always going to add up to 3, right? Because it's 4 3/4 of a melon. 4 times 3/4 is 3. So it's 3 plus, there's 2 halves and 2 more halves. So 3 plus 2 is 5. In step 2, we've got that 3 from the corners and 1, 2, 3, 4. So 3 plus 4 is 7. In step 3, we've got that 3 plus, let's see, 3 and 3 would be 3. 3 halves and 3 halves would be 3. And then again, 6. So 3 plus 6 would be 9. And then in step 4, we're predicting 11. This is looking a lot like I expected. If we take the difference, we see 7 minus 5 is 2, 9 minus 7 is 2, 11 minus 9 is 2. It's a constant in the differences. That means this is a linear pattern, and we can use this equation for a line, y equals mx plus b, to model that. Our difference between each step is the slope of that line. So we put that in for m. So y equals 2x. And then we're going to add something to make it work out with the numbers here. In step 1, we said we have 5 melons. If we just use this equation as we have it now, y equals 2x, we'd put in 1 for the step number, y equals 2 times 1. That would only equal 2, but we've got 5, so we have to add 3 more. And actually, the way we can think about this is that b is the corners, and the 2 times the step number are the melons that fill in, the half melons that fill in the sides. So I think our equation, we can add this plus 3 here, is going to be y equals 2x plus 3, but let's double check this with a couple of steps. So in step 2, we'd say y equals 2 times 2 plus 3. That'd be 4 plus 3 would be 7. Yeah, that's how many we got in step 2. Step 3, y equals 2 times 3 plus 3. That'd be 2 times 3 is 6 plus 3 is 9. Yes, this is checking out. All right, so we've got our equation. Pretty straightforward linear equation. To find the melons in step 43, we'll just plug 43 in for x. So y equals 2 times 43 plus 3. And let's see, 2 times 43 is 86, plus 3 is 89. So 89 melons in step 43. Looked like it was going to be harder because of these fractions, but not too bad in the end. How did that go for you? Did you get 11 melons in step 4? Did you come up with an equation like this? Let me know. Thanks, everybody.